But hello, Germany. Good morning. Um, I'm really happy to be getting up at this time in the morning because I absolutely love going to Germany. Before all of this stuff happened, I used to go there 3 or 4 times a year, which is a little bit strange for somebody who lives in Australia, but I keep forgetting how terrible that flight is. So yeah, good morning, Germany, Europe, anyone else that's silly enough to be awake in a different time zone like me. I'm Mike. I'm a web developer from Sydney, Australia. And at the time I was writing this talk, I had no idea what god awful hour it was going to be. And since I've just crawled out of bed, really, I still not sure 100% what time or day or year it is. But that's pretty much what 2020 has felt like. Nonetheless, it's actually great to see your lovely faces. I'd planned to sort of like say, I always like plan an introduction for talks because, you know, if you freeze at that moment and don't know what to say, it's always nice to sort of have an introduction plan. So what I was going to say is it's great to see your lovely faces, only I can't. But the thing is, I've never been to an online meetup where I actually have seen so many people with their camera on and seeing their faces. It's normally like a really strange experience. I've given a couple of them. So thank you so much for that. I actually am seeing your faces. But what I was going to say is we can't because of this stupid pandemic. But I mean, we can't be face to face, which is a little bit different, but it's okay. This just means that we get to use our imaginations. So to help establish the atmosphere, I've put a few little like descriptive captions on my slides, and I want you to keep an eye out for those during the talk. This will help give an idea of what like you're watching Netflix. I really love reading the descriptive captions. Anyway, let me start by setting a vivid scene for you. So just pretend it's a warm summer's evening. You're walking to the venue with a gentle, cool, refreshing summer breeze on the back of your neck. You've arrived early to mingle, and tonight CSS Café is completely sold out the Friedrichshain Palast Theatre, and the room is full of energy. People are chatting. You take a seat near the front. As I approach the stage, the din of the crowd begins to soften, and it feels like the audience takes a collective breath in as I begin my talk on the history of container queries, according to Mike. So for those less familiar with the concept, container queries describes a non-existent but largely hypothesized feature of CSS. And I think that it's safe to say at this point that container queries are the most requested feature in CSS ever. And as you can see, my highly scientific data analysis would seem to back that up. How do they work? It's a fantastic question, audience member. The answer is they don't actually work yet. We don't really know what the final syntax will be, although there's perhaps a little bit more of a solid proposal for that now, and we'll talk about that later. But conceptually, they work a little bit like media queries. The key difference is that rather than responding to the viewport, they respond to the space available inside a container, as the name might suggest. And this makes a lot of sense, right? We design layouts and components, and typically our layout should respond to viewport constraints, but our component should probably be responding to the constraints of the layout. Now, at this point, I had recorded a video demo so that I didn't have to give a live demo at 3 a.m. in the morning. But that audio, getting it all working with this ridiculously complicated setup didn't seem to be worth the trouble. So I'm going to do it live. So anyway, this is the demo that I have for you. And I have a bunch of components over here on the right-hand side. I also have a layout here that you can see. Hopefully you can see those dotted lines. Is that nice and visible for everyone? What happens is if you drag a component into one of these containers here, it's going to fill the available space. So you can see when I put it here, it takes up 2 columns. If I was to put that over here, it's going to take up 1 column. I have to give a shout out to Phil Walton too, who I stole a bunch of this code from in order to make this work a little bit quickly. But you can see similar with a card component, if I drag that into a space where it's able to be sort of in this media object type format with an image and text side by side, it will do that. But if I put it over here on the on this side, then I get sort of a card pattern. Let me just rearrange this how I like it. There we go. So yeah, you can sort of like design a layout like that. And the cool thing is that if you have a layout that responds to media queries, so for example, if I was to change the space available for this layout, eventually a media query will kick in And you can see that that particular layout there has gone to a single column layout, and all of the components inside those containers have responded accordingly because they're not responding to the viewport constraints. Now, you could hack this up with media queries and so forth, but the reality is we have very component-based design these days, and you don't necessarily always know where a component might be used. It might be in a sidebar, a footer, a header, maybe in the main body content, or maybe like there's a grid of, I don't know, gallery images or something like that. You can probably imagine all of these scenarios where you might want to use something like that. So you can see from that demo that layouts and components there are responding to different constraints. That's the demo. That's pretty much container queries. So here's my hot take on all of this. Those concepts of layout and presentational components is something that's kind of muddled in CSS at the moment. In CSS, there's really no clear distinction between presentation styles and layout styles, yet I feel like this is a separation that is so often needed. And if you've read any blog posts I've written or seen some of my talks, you might know that this is something that I've advocated for on numerous occasions. And I think this lack of separation is at the heart of the problem with container queries as well. And you might, if you've been following this, you might be aware that there are some challenges or some problems with container queries. But before we actually talk about like what those problems are, let's look at why those problems exist. And one of my favorite things to indulge myself in is to sort of like talk about and look at the history of the web. Now, honestly, hang on, I probably went back a little bit too far in researching this, but there's literally nobody here to stop me. So you're all going to have to indulge me on this. I went back to 1945, right? In 1945, a device called a Memex was like described in a research paper, but never actually built. And that's the image on the sort of the left-hand side there. So the idea was this desk containing these rolls of microfilm. If you know what microfilm is, it's like, you know, you can look that up later. So it had these rolls of film, and how I think it worked is there was this like electronic index where people could punch in a number, and the gears would like rotate, and they would like move to a specific index on those rolls. And then within those rolls, you could like reference another index on a different roll, so you could kind of like link one document to another within microfilm. And then they punch it in, and the gears would go again. And I think that's really cool. It's kind of like on the verge of like computing, like somewhere between like a mechanical device and electronic device. And that's really interesting, whether it's sort of like, oh, I find it interesting anyway. Let's move on. And then in 1965, the term hypertext was coined. Again, this was like all theoretical at this point, but during the 1960s, there was a whole bunch of research around like linking and organizing documents within computing systems. Some of these systems were built, but at this stage, all of these applications are just largely academic. And it wasn't until the 1980s that we saw the first commercial applications of hypertext arise. In fact, it wasn't even until 1987 with the release of something called HyperCard, and we may actually have some now at this point in the story, there may be some developers here who actually remember using some of this. But HyperCard was available for home computers, and suddenly this idea of hypertext really took off. So it's important to note here that all of these were sort of like local database systems, and all of this happened prior to the web. But the reason I'm mentioning it is I think that context of like document linking systems is something that's like still really important. Anyway, on with the history side of things. By this point, the environment was right for the web to emerge, and this happened in 1989. The web and HTML were invented, and you all know something of that story probably, so I'm not going to go into that. Basically, the web was invented at CERN, at a research facility, during the collision of particles at high speed. The web sort of just spun out. So I won't go into that story, but what's interesting about it in the context of container queries is that the first version of HTML didn't contain any styling whatsoever or any kind of layout system. It largely reflected these document systems that came before it, and for a few years still, it would be mostly used for linking between documents at CERN and a handful of universities. Right, so don't forget to throw in any questions if you have them. You can interrupt me now if there's anything at this point. I'd love to chat about history. But anyway, we can also move on to the next phase. This was kind of like the phase where the web sort of jumped out of CERN like a virus. It began to sort of spread around the world. And in 1994, CSS was proposed. The problem was everyone hated it. It was sort of like a lot of resistance from the original sort of academic creators at that time. In 1995, stylistic attributes were added to the web. Those are things like the BG color and font face on the HTML attribute and stuff like that. Definitely all in caps. There's probably some of you that remember or still maybe even have to pick up an old site and see some of this stuff. And what's interesting here is I'm pretty sure that like browser vendors were the one that forced these features upon like the spec writers rather than the other way around. In 1997, CSS became an official standard. And again, this is only after Internet Explorer implemented many of its features. And in 1999, HTML4 became the official standard. And this was once again, somewhat retrospectively after these things had already happened. So it's safe to say, I think that at this point, the spec horse has absolutely bolted and the browser wars have kicked off. What I mean by that is these things were being implemented like faster than the specs were being drawn up. And what you can see here is that CSS emerged under pressure from early adopters as a solution to something that the academic gatekeepers, perhaps, or maybe not all of them, but many of them didn't really want. And because of like that environment and the original sort of document linking system origins, I think we're still constrained by these things. And it's important to remember that still up until this point, there's no dedicated layout system for the web whatsoever. Over the next decade, we're going to rely on tables and later on an unintended side effect of floats, something called a clear fix. And can we all just like take a moment to appreciate like how much of the web's information sharing, commerce, and other forms of business relied on this hack for like more than a decade? That's one of my favorite pieces of web history, and I just find it like pretty amazing actually. So anyway, we're getting pretty close to the birth of the container query idea now. But recognizing that there is a problem with no dedicated layout system, in 2009, Flexbox is proposed. But don't be holding your breath for this, because it will still be half a decade before we can use it. And this is going to be something of a theme that will emerge throughout this talk. And that's not something that really bodes well for container queries. But hey, I guess we still got it sooner than Berlin got a new airport. So that's good. Is that joke still working, or is it like now? That's old now. Okay. Anyway, it was a similar story for media queries. In 2001, the first draft was published, but it wouldn't become a recommendation until 2012. And once again, this is only after browser vendors sort of shipped media queries. And in this case, TechBro is kind of right. There were some people who foresaw the coming of the mobile web, but like we didn't actually have like iPhones or anything at this point. So at that point in time, media queries for many people were like intended to be used for something entirely different. And I think it was very few people who were about to see what would happen. Perhaps Ethan Marcotte was one of them. For me, the real history of the web starts in 2010 when he wrote this now famous A List Apart article, Responsive Web Design. And that was, I think, like the first time that term was really coined in a popular space where lots of developers read and learned about it. And it exploded from there. For a lot of people, this was the first time hearing about responsive web design. I can still remember that period. It was a really exciting time to be a developer, actually. And like, I built some really early responsive websites, and we were still getting assets from designers and things like that, like, was really tricky. We were sort of like switching between like two completely different versions. I don't know if anyone remembers building M.dot websites before this, like completely like where you actually sniffed the user agent and served a completely different website. So like people were trying to like switch these over into responsive. Anyway, super interesting time. I'm glad it's gone, but yeah, for many people, this was the first time they were hearing about responsive web design, and we were all sort of like grappling with the new ideas and the best ways to do it. Even at this point, some people were already looking ahead to container queries. Now, the exact origin of container queries is a little bit cloudy. It probably emerged from discussions on W3C mailing lists, IRC, and other places that like spec people like to hang out. I personally recall some discussions from around this time, but when I went to do research for this, actually finding those sources proved more difficult than I expected. And a big thanks to Zach Leatherman, who documented a whole bunch of sources. There's a really good blog post that he wrote on the history of container queries. I pretty much ripped that off for a lot of this talk. And it was through that I found this Twitter discussion between Ian Storm Taylor and the lovely Paul Irish. And what I think is important about this particular conversation is it points to earlier discussions that were happening in official channels. Paul Irish works for Google Chrome, so would have been aware of that as well as other channels at the time. So that's one of the earliest sort of like references to it dating back to prior to 2011 that I can find. But just like sort of the academic resistance to CSS, at this time there was a lot of resistance to the idea of container queries. So it might be time to talk about that problem I mentioned earlier. There's some pretty significant challenges for browser developers in particular, and some that might require rethinking like the fundamental approaches to how a browser renders a page. And you could argue, and I would argue, that this is something that is long overdue given the history of the web and how it evolved. But putting that aside, let's just discuss the problem. There's a lot of ways in CSS for a container's dimensions to depend on the size of its content. So it can respond, content can respond to the size of, if the, sorry, blah, blah. It's too early. Let me have a sip of water and try again. If the content can respond to the size of the container, and the container responds to the size of the content, then you've potentially got problems with recursive layout. So let's take it really slow and go through how it works. Typically, elements in HTML will resize to fit their content. So imagine that you've got this image here and it's 400 pixels tall and it's about to be loaded. The browser says, no worries, mate, I'll load this for you and I'll change the height of my container to fit the image, right? We all know how that works. So the container is now 400 pixels tall, the one on the right, with whatever padding it also has. So now imagine that you've got this container query, and that's the current proposed syntax, I think. And don't worry if that looks a little bit alien to you. What it basically says is when the container is taller than 200 pixels, make the image 100 pixels tall. So what happens? So the first render, you get this, the image loads and it's 400 pixels tall, making the container taller than 200. So now that container query is going to kick in. And what it will do is it will make our image 100 pixels tall. So this is like the second render. But now the container isn't 200 pixels tall anymore. So the image is allowed to be full height again. But now the image is taller than, the container is taller again than 200 pixels. So the image will be smaller again. And this is where we get this infinite loop, right? So what do we do about it? And this problem that I've described can happen on the horizontal axis as well for inline elements. And that's probably like the majority use case for a lot of container query problems. But I think like this idea of an image loading is a really simple example because it's something like we've all seen, whether you've done much responsive design or not. It's one of the first sort of like things you encounter. Anyway, getting back to what I said earlier about the separation of layout styles and presentation styles, many of the problems with circularity go away if we have dedicated container elements for layout that don't respond to the width and the height of their children. So as I said, our layouts typically respond to viewport constraints, and it's feasible that the sort of aqueous presentational components there in my little sketch could be responding to their containers without being able to affect their width and height, right? So there is an argument that we already have something like this. So if the presentational components can't affect the width and height of the containers, we already have something called iframes, which pretty much do this, right? And if you just had an involuntary gag reflex, it's not Tailwind, it's totally understandable. It's iframes, right? Iframes come with a heap of baggage, both technical and emotional. They're effectively like an embedded page with a complete document context, isolated styles, scripts, everything, right? And it's just like multiple web pages almost. So this has a pretty significant performance impact. And that's one of the other main technical challenges facing implementers of container queries. And that is, how do you make them performant, right? I think we can overcome all of these challenges, and I don't know what the final solution might be, but I'll be willing to bet that behind the scenes, it's probably going to look like some kind of isolated container element that hopefully feels nothing like an iframe. Regardless, I'll keep structuring documents as a combination of like layout and presentation styles and isolating those concerns accordingly so that I can build responsive designs using other techniques and replace those with native container queries when that comes. This might be a good point if anyone has had any questions up to this point to throw them in the chat. As I sort of go into the other chapter of solutions that we can use now. All right, I'll keep moving on. If you do have any questions, please throw them in there. Jumping back to the birth of container queries, a huge amount of credit has to go to Andy Hume, who developed this selector queries library, and I'd encourage you to go back and have a quick look at it. This was developed in unbelievably 2011. So this was sort of like the same year that media queries became available in some browsers, basically. So very early days. And if this isn't one of the first examples of something that is soon going to be called element queries, so this, you'll notice that Andy didn't even call it element queries, or element queries was like the name for container queries before container queries. And Andy didn't use either of those. So I think this could be one of the earliest references, or at least very close to it. And without taking anything away from Andy Hume's original idea and his implementation, it's pretty clear that this was an idea that the web community was going to have. Pretty soon we had a whole bunch of like different techniques for achieving element queries, mostly with JavaScript. A lot of people were talking about it, but not many people were using it in production at this time because JavaScript in the early 2010s wasn't really up to the task of performantly watching for resize and mutation events on the DOM. And you still had problems that you had to deal with in JavaScript around like circular updates and things like that. So it was kind of tricky, but all of this was about to change. Between 2013 and 2014, Flexbox would arrive for Firefox and Chrome. And this was about to be an absolute game changer, but more importantly than that, a fundamental change in thinking about layout on the web. There's probably a lot of people here who sort of like lived through that era of web development. And it really, like, now that we've been like several years in this space, it's really interesting to see how big an impact that has had. I think this is the change to Grid and Flexbox has been one of the biggest changes for the web. For the first time in the history of the web, we had a real layout system. It even had algorithms for calculating layout based on the content and various constraints that you could set with CSS. And I remember when this came out, or even just before it came out, I spent like days reading the specifications, and I wrote a blog post even that detailed exactly how Flexbox algorithm works. I even wrote a JavaScript calculator to try and figure out flex basis and shrink and grow values and how that, basically a JavaScript implementation of the algorithm. You can still find that JavaScript calculator somewhere on the web if you wanted to search for it, but you probably shouldn't. So anyway, we didn't know at the time, but this was about to be the birth of algorithmic layouts. So Flexbox itself is an algorithmic layout. So that's kind of like the first algorithmic layout. I'm not entirely sure where the term algorithmic layouts came from. It might have been something that Hayden Pickering, if you know, he's a developer from the UK. He probably named it because he's bloody good at naming things, but I'm not entirely sure. Either way, him and Andy Bell packaged together a whole lot of examples of algorithmic layouts on a website called everylayout.dev. It's every-layout.dev. If you haven't seen that, I'd highly recommend having a look at it, especially if you want to learn something more about algorithmic layouts. There's a whole bunch of examples on their website. So obviously, as I said before, Flexbox is an algorithmic layout in a sense. Realistically, all layout on the web is driven by some kind of algorithm. In fact, the entire web is driven by some kind of algorithm. It's algorithms all the way down, basically. So what exactly is algorithmic layouts? For me, I think it's more about like understanding exactly how these layout algorithms work on the web, and not just the layout algorithms. In fact, like understanding how things like calc and min and max and all the other like tricky bits, all the algorithms in CSS, how they work, and then using them to achieve perhaps unintended responsive behaviors, things that go beyond the scope of media queries. And that's back to that talk that you mentioned earlier from Freiberg in many years back. So this is like a space I've been interested in for a long time, actually. If I've had any kind of influence on the web, which I probably haven't, but maybe one person at least, so that's nice, it would be in this space. Some early examples of things that I would call, maybe not algorithmic layouts, but like at least the birth of these ideas, is fluid topography hacks with calc, quantity queries, responsive SVG techniques, dry switching with CSS variables, if anyone's read that article by Anna Tudor, and then later on the Holy Albatross and Raven techniques. I'm going to talk about some of these very briefly, but I might not dive into the really specifics of the code just because it's far too early for that. So this is a technique that I think I might have come up with, and this is like a way to get fluid responsive topography on the web. But like most things on the web, I'm sure this was discovered independently. This is just a lerp, if anyone knows what that is, a linear interpolation. What we're doing is we're using viewport units here. So it turns out that 100 VW is like a variable. There's a very few number of variable things in CSS. And if you can put those variable things inside a calc equation, you can do mathematics with them. And all this does is it sort of like interpolates between like a minimum font size and a maximum font size over a minimum screen size to a maximum screen size. So you get this kind of fluid topography technique, and you don't have to use it with topography, right? You can get like these responsive like widths that will like start off at a certain size, and then as your browser window gets bigger, they'll stop at a certain size. So this is like an early example of like, I guess, and this came about not long after calc was implemented. So I just happened to jump on that idea early and try and break things with it. And it's fun to do that. And sometimes these kind of things emerge. And that's kind of how other ideas like this have emerged. So this is quantity queries. This is one by Hayden. The idea is basically being able to apply styles depending on how many things exist inside a container. And with clever use of nth child and combinator selectors. This one says any LI elements that occur after the sixth element, if they have exactly that many, then make them green. That's a terrible explanation, but that's all you're getting at this time. Hayden describes it as creating style breakpoints for quantities of HTML elements, much as you can already do with media queries for viewport dimensions. So yeah, this example here, that's the code from the picture you were seeing before. If you do that, if you have exactly 6 elements, the color is going to be inside a container, the color is going to be green. So that's kind of quantity queries. Once again, if you have any questions, throw them in the chat. I'm happy to talk about all of these techniques with you. The next one is responsive SVG techniques. Now, SVG is a little bit like an iframe in some contexts because it has like kind of has a document context in its own sort of, what's the word I'm looking for? I would remember this if it wasn't so early. A positioning scheme, right? So it has a different positioning scheme to the web. And you can do things like this, where like, this is actually an image that references an SVG. And that SVG has some like clever stuff in it that says like, show and hide different elements inside the SVG using CSS depending on the width of the container. And the image provides like a context for that container. So you end up with these like responsive images with no extra work. And there's also a technique that Estelle I cannot remember how to say her last name. She wrote a blog post called the clown car technique. This is actually a blog post I wrote here. You can see that in the last bit there, I'm about to talk about container queries. So yeah, all of these ideas was like hinting towards things you can do. And Estelle's article is much the same. She does a bit with, I guess, responsive images prior to picture and source set. And then we have dry switching. This is an article on CSS tricks by Anna Tudor. Now, the way this one works is you can see that there's like a toggle on and off. Now, that is just setting the value of a custom property to either 1 or 0. And a little bit like what we showed before with the calc equation and using viewport units as a variable, we can use like 1 and 0, like a binary number, to do a whole bunch of different mathematical things that have results. And in this case, rotating a box. But you could do more than that. And you can use that one variable in multiple places to do multiple things. And you can make those variables work with media queries or something else as well. So that technique sort of like opens up a whole lot of possibilities of things you can do as well. And then later on, again, Hayden Pickering is very good in this space. He came up with this technique for using Flexbox to switch between basically having what you see there. So see the 2 black bits, you can go 3 items in line and then like later on stack them, right? But what normally happens with the Flexbox algorithm is you have this intermediary space where like 1 starts to wrap and you have 2 side by side, and that sometimes that's desirable, sometimes or quite often it's not what you want, right? So Hayden came up with a way to sort of avoid this. And I think I have an example of the code there. I'm not really going to explain that in great detail, but you can see it again, it's making use of calc and custom properties and stuff. And then came the Raven technique, which puts dry switching together with some of the mathematical techniques that we talked about before. Surprisingly, this one doesn't use Flexbox, and this is only part of it. And I'm definitely not going to explain this one. Suffice to say that it builds on the techniques that I mentioned before. So I'd love to explain this in detail actually in another talk, but I really need to dedicate like an entire sort of section of a talk to that. And that's not really where I wanted to end up with this one. There is one other technique that I do want to explain in a little bit more detail. I should say too that the Raven technique is probably like the closest thing that we have to actual container queries. So if you're interested in it, do go and read the article and check it out. But the one that I want to talk about is the FlexGrow 99999 hack, whatever. That's what I'm calling it. It's one of the earliest examples of an algorithmic layout that I know. And it's probably by someone that you haven't heard of. And his name's Jean Van Hee. You can probably find the blog post if you're interested. But I should mention too that this one is built on a lot of work by Zoe Mickley-Gillenwater, who was doing blog posts and talks and things about Flexbox in the very early days. That's where all of us who are interested in it learned about it at that time, around 2013. This blog post isn't dated, but I do remember it from the very early days of Flexbox. I think it's probably from 2013. And it works a little bit like this, right? So on the left-hand side there, you can see you've got a container. Inside that container, there's 2 elements. There's an image, and there's like a container that usually contains a description, text, something like that. And it's a way to switch between like the card pattern. So remember the components that I showed you before. The card pattern had like a stacked version and then like a media object pattern where there's an image and text side by side, which forms the basis of like comments and all sorts of other things on the web. So anyway, you have that structure, and then on the container, you set flex and you set flex wrap. On the first item, you set a flex grow value of 1. And on the second item, you set a flex grow value of like 9999. And what this will do is you can also set a flex basis on this so that when it's side by side, the image gets a sort of desired width. But what this allows is when there's enough space, they'll be displayed side by side with the image using the flex basis value. And because the second item, I've got a typo in my code. Look at that. That bottom statement shouldn't say image. It should say paragraph. Sorry. So yeah, I'm so tempted to fix that now. The second one should basically grow to fill the available space. But because it has such a high flex grow value of 99999, it's going to be allocated 99.99% of the space available, the extra space. So it's going to its grow value just dominates the other one. So it's really the only one that grows when they're side by side. When they wrap onto their own line, they're still both able to grow. So the first item still has a grow value and 1, and it's allowed to go full width. And the second one has a massive grow value, so it's still allowed to grow as well. So that's how you're able to toggle between the sort of the card pattern and the media object pattern. And the reason I sort of like show you this technique is it's actually one of the most accessible and most reliable little techniques for getting a responsive component. So this is one I'd really recommend using if you need it. And you're probably all wondering now, are algorithmic layouts the future of layout on the web? And I'm not sure if algorithmic layouts are what the next generation of the web will be built on. Algorithmic layouts are a collection of hacks to achieve limited and specific responsive behaviors. The history of clearfix and floats might suggest that hacks and things are a stable platform for at least a decade. But I think that those clearfix techniques were a little bit different. They sort of became a de facto standard, and it did like one specific thing. As well as that, I think that the web is a whole lot more mature now with a whole variety of different types of developers with diverse skills, backgrounds, and it's not really the same place it was in the early 2000s. And it kind of breaks my heart to say it, but I'm not sure that algorithmic layouts will push the web forward in the same way that clearfix did. They're clever as heck, and I love them, but they require really specific CSS and layout algorithm knowledge to implement successfully, especially in large-scale projects, no matter how nicely they're packaged. And that doesn't mean that I think we should stop using them or exploring them. I just don't think that they're going to have as wide a reaching impact, obviously, as clearfix did. I'd still recommend learning about them and using them in specific cases. I think it's really great knowledge to have, and I think they can be a really useful tool in our arsenal. But sadly, I think it might be JavaScript that fills the stopgap until we get native container queries. So in 2018, RESIZE Observer, after lots of discussion, finally landed in Chrome. RESIZE and Mutation. Well, Mutation Observer, I think, arrived a lot earlier, but now we have both of them. So it wasn't until, even though it landed in 2018, I don't think it was until 2020, actually, that we got full green browser support across all major browsers. And what this means is that those JavaScript solutions that I mentioned earlier can now be a whole lot more performant and viable. So this is what I think might eventually be replaced with native solutions. But let's have a quick look at what we can do now. So this is a resize observer here. So you can see that you declare a specific resize observer, and you just say new resize observer. Then that will give you a whole lot of entries. So it will give you all of the sort of elements that match. So with those matching elements, then you can actually look at the content rect width and content rect height and get the dimensions of those elements. And then down the bottom, you can see that you use that, you say to that observer, I want you to start observing this container. And it will look for anything and the interesting thing is like it will look for resizes on just that element, not the entire browser as well. And it will also detect resizes that happen as a consequence of something else. So like, for example, if you put more content in there, that's going to cause a resize as well. So if you're just listening to like window resize, you might not get that. So resize observer is like super useful. Previously detecting that stuff was really, really hard. Resize observer also avoids these infinite callback loops that can happen with these cyclic dependencies. Basically, what it does is it only processes elements deeper on the container in subsequent frames. I'm explaining this really badly, but basically it avoids a whole lot of challenges similar to the challenges that we had with container queries, which is why I think Resize Observer is interesting because it points to some possible solutions to that problem that we mentioned earlier with container queries. So finally, getting towards, we've gone from 1945 to today, basically. And hot off the press in the weeks prior to this talk, Chrome announced an intent to prototype container queries. And that's browser spec talk for, yeah, we'll give this a crack. What this means is they're going to prototype and develop some solutions in Chrome that we might be able to test behind a flag or something soon. And this implementation is going to be based on a proposal by Miriam Susan, who you should all follow and has done a huge amount of work pushing forward this and other specs in CSS. So go and check that out. And that's actually all I have for you. There is another part for this talk in a couple of weeks, hopefully, where we actually get to play with some native container queries.
So hopefully I'll be adding that soon. This was a whole lot of fun. Thank you so much for having me. If you have any questions, please throw them in. I've got plenty of time.